we'll talk on forage production and carbon farming in Italy. Also, Laszlo called some people to give to the webinar some more input for the discussion. And that's it, Laszlo.
Okay, thanks.
You're welcome. Thank you.
I could sort out this issue. One more thing I need to set up, so I need a second. Because I'm using two computers and there was some little loop. Okay, another technical information that because we have several presentations, then maybe if you have any question or comment, you can use the chat and we can review them when we go through each presentation. We will also upload the slides, of course, to our platform and the video as well, so you will be able to find them. We have to shorten our talk and not to read out the slides because we prepared with 6 introductions, I would say, to certain topics. When we first met online with Alex, we tried to elaborate some idea which could be a common topic for the first knowledge exchange event for us, and the carbon farming topic could be some common point of activities and interests. So that's why we are starting with that focus. And when it was discussed the first time, what came to my mind is an ongoing project. It's an Interreg project that is called Boosting Carbon Farming in Central Europe, where we collaborate with the different experts and colleagues whom I invited. But of course, our own organization, OMKi, is also involved in very relevant techniques, regenerative agriculture and other methods, which include carbon sequestration. So I'm not going to read out now who will present because you will meet them soon, within a few minutes. And also why we invited more than just 2 or 3 speakers, because we would like that each type of main AKIS actors present. So we have someone representing advisors, some farmers, researchers, or the private sector as well among our speakers, and we would like to widen the network. We shared the invitation publicly. I saw some person who I know, and they came from outside of the project, internal partnership. So I think it's nice to try to widen our network as well. So these presentations will be very brief, like a few slides each, but could serve as a kind of maybe as an appetizer or to establish the contact points, and then in the future it could be further discussed even during our knowledge exchange events, or you can if you're interested in their activities, you can contact them each and follow up on these presentations. Already on the SharePoint we uploaded the slides, so you can find it on that address or in this folder on the Climate Smart Advisors SharePoint drive. And also on the website there is an introduction about myself. I'm not that much forage production expert, despite my dissertation at the university was on this very topic. But more, I was involved in the organization of advisory networks and coordination of service provision for the last, I would say, 30 years. And my main specialization was rather digitalization, ICTs. But in the last 5 years, I joined OMKi, and you know, it's an organic research institute, and of course that I refreshed my knowledge and developing and learning until long life in this topic. It's an endless and very interesting topic. So about the Interreg carbon farming project, it's running until the next year, and we have 9 countries of Central Europe represented by 11 partners, and the 2 main type of activities, work packages are agrotechnical experiments, field trials, and the other one is related to testing what we call business models or cooperation models. So if you just type in the Google search carbon farming and CE or Central Europe, you will find that project. We try to classify the different techniques of carbon sequestration by 3 types, 3 main types. Then we can add external carbon to the soil, when we can use plants to incorporate it, or when we can preserve the carbon content in the soil to avoid its loss. And you can read from the slide what are these 8, maybe 10 techniques we are testing in each country. We done field trials. At least 4 types of techniques should be tested during the 2 years of that period. Of course, it's hard to measure or to reach the physical increase of carbon in the soil during that short time, but we can still realize some good benefits and good impacts in other areas as well because of these techniques. And I highlighted maybe 2 of the techniques, the relocation of harvest residues for animal nutrition, and the use of cover crops and catch crops can be also relevant. These 2 especially relevant in forage production. And actually in Hungary, one of the partners who is participating in the project, they do forage production, and they joined the carbon farming program, and you will hear both the farmer and also the company who runs this carbon farming project, type of carbon credit project in the next 2 presentations after the Austrian presentation. Okay. So business models and cooperation models. So this is the other main focus of this project. When we try to identify what could be the main motivation, what could be the advantages and benefits, or the difficulties and the problems and challenges to implement such programs, and how we can attract farmers, and what are the main concerns, what are the main impacts during these activities, and each country selected a type of carbon farming cooperation business model. So on the slide you can see some of the different options what or partners in the different countries are testing. Basically, the 5 main types are farmer-led cooperation, the ones when it's between the farmer and the processing industry, food industry. There are examples when farmers collaborate not with food processing and through the food chain, but with other type of companies like maybe banks or insurance companies and others. Also, we have some examples, government-led. Eco scheme for the common agricultural policy is one such. When some countries have carbon sequestration oriented undertakings for eco-scheme. And also, we think we identified a new type, which is coming from the knowledge transfer orientation. So like advisory companies or some projects as part of their advisory service support farmers how they can take part in carbon farming and boost carbon sequestration. Okay, so that's my introduction regarding this project. You will hear some practical follow-up or presentation coming from this broad background of the project. Currently, we are summarizing and reporting these results we already have in the first 2 years. So they will be available in the first half of this year. You can find a description of the trials or the cooperation models in our publications. And this project will still run for 1 more year to disseminate and upscale results. Okay, so that was my slide, and I stopped sharing. And I think that Christoph will be the second speaker. Hi, Christoph.
Hi, Laszlo.
Okay, we can hear.
So thank you, Laszlo. Thanks for inviting me to this event, and good afternoon to everybody from Vienna. I will now try to share my slides with you. Hopefully it works out now and you can see the first of it.
Yes.
So thanks. So my name is Christoph Reithofer and I'm project manager and scientific assistant at the non-governmental research institute Bioforschung, Austria in Vienna. I was strongly involved on 3 projects that at least touch a little bit the topic of today, forage production and carbon farming. And based on these projects, we developed this cooperation idea that I'm now going to present you in a very short and brief form to keep the timetable. I'm also, beside my work at Bioforschung, I'm also a small-scale farmer by myself. So I've got a little bit experience too in forage production. The original view of the European Union. So how can I go on? Excuse me. So yes, the original view of the European Union was that they prefer carbon farming business models that are result-based, so that are data-based. They had a specific output of a certain number of carbon that can be sequestered to the soil per hectare and years, for example. So this was the main assumption at this business model. Here we have just a brief overview of the different views that how forage crops can be utilized. So today I'm speaking to you about a relocation method of the green cuttings of clover grass. So we are talking about a variant of storage, the biomass, and then in my example it will be converted under anaerobic conditions to a silage product, which then can be used as a fertilizer, as an organic fertilizer, and applied on a field where a humus decreasing crop is grown. Speaking about result-based cooperation models, business cooperation models, there are always 2 main questions. The first is how do I get valid data, objective data? And the second is who controls the data? So first, to dive directly into the topic, I will give you a very short overview about the method behind the data evaluation and the calculation of carbon sequestration in this context. We use the method at Bioforschung. We do use and redevelop the method of a site-adapted humidification model after Kolbe. That means all Austrian soils are divided into 6 categories The first category is, let's say, rather non-active soil that can be soils like with very high water content, for example, where mobilization processes takes very long. And it goes up to the sixth category. These are very active soils with a higher amount of microorganisms, with an high amount of nutrient mobilization permanently. So in Austria, we have the data based on these categories for quite a long time because of the evaluation of the soil's values by the government. This is the main base, but they also we added some soil parameters to this classification. So here we have the 6 different site categories of Austrian soils, and on the left side you can see different crops or different crop categories. The cash crops, as you see, they are humus decreasing to a certain extent based on the soil category, like sugar beet or potato. They have a negative impact on the carbon balance of the field where it is grown in that year, in that very year. Also, maize has a very negative carbon balance. That's nothing new. Cereals and oil plants also are slightly negative. And today we are speaking and focusing on perennial forage crops, which of course have a very positive effect, depending on the duration they are at the field. Also, cover crops have a positive effect on it. So that's the base of the calculation model of the humus calculation of the humus balance model after Kolbe. The second type, and I have to apologize because some parts of it are in German. The second type of the positive impact on the carbon balance are, of course, the organic fertilizers. I put the English names beside the German names, and I tried to explain it very briefly. Here we have, for example, the solid manure, and we have 3 different coefficients that mean the first 10 tons of solid manure applied to a field raise the carbon sequestration on it by the amount of 33 kilogram carbon per ton fresh matter. The 11th to the 20th will just increase the carbon content for about 26 kilogram carbon per tons and fresh matter, and over 20 just 23 kilogram carbon per ton and fresh matter comes into account. So you cannot put 1,000 tons on the field and calculate it like this. So there is a decreasing effect of the carbon sequestration by the amount of organic fertilizers you apply on it. I'm sure we agree on that. Today I'm speaking about the silage fertilizer, and in our projects we evaluated the dry matter and the carbon content, and it's about similar to solid manure. So these numbers are part of the calculation which I'm going to present you. Just a few general assumptions. As we can see before, depending on the Austrian soil type, 1 year of forage crop cultivation adds from 460 to 850 kilogram carbon per hectare and year to the soil. And we're speaking about a long-term carbon sequestration. The data on which this humus balance method is calculated are always to European long-term field trials. And these show that the ceiling of the carbon storage per hectare and year can be summed up like about the amount of 500 kilogram carbon per hectare and year. More isn't really possible on a long-term way. So the conclusion is that the relocation of clover grass biomass doesn't affect the carbon sequestration on the donor field where it's been where it's cutted negatively, because the numbers show us 1 year of forage crop cultivation adds nearly 500 kilogram of carbons at the least active soils, excuse me, at the active Austrian soils. And so we can easily use the above ground biomass, cut them and relocate them to other fields where they have just a bigger use for the carbon sequestration. Exactly, this is the conclusion. The carbon sequestration of the cutted green mass is only about 40 kilogram per carbon hectare in the year. I think that's the most important number on this slide. There are several other benefits which I put in the list here, why it does make sense to relocate the forage biomass. The field trial I will present you very shortly. Yes, I think I will just show the pictures. So the clover grass is mown, it's put it in a place to dry and then put on a straw. Then it got harvested, relocated. Here our trial farmer also puts some additional microorganisms to the silage heap. Then it's been covered with a plastic foil, as you do with anaerobic processes. After about half a year, he picks it up again and applies it like compost with a compost spreader. At the beginning of these trials, we weren't exactly sure how this silage can be applied onto the field, but it was really practicable. So there wasn't any difference from applying compost to a field. 4 weeks after application in this winter hardy cover crop with mainly rye, the fertilizer still was intact. So speaking in terms of nutrient mobilization, we have to consider that it's just a slow nutrient release out of this silage product. So now I come to the business model itself. I tried to show you that there are some benefits while growing forage crops in the crop rotation, and also there are additional benefits by relocating them. So based on the humus balance, which is calculated for the whole farm, it is possible to show a positive impact of them in a specific number. And then the idea was just for farms with a on-farm gate marketing, they could label their products with a, let's say, carbon farming labeling, and they just sell the products for a higher price, because we assume that there are at least a few customers who appreciate this these sustainable ways of cultivation, which we can put in figures and numbers, and that they are willing to buy these products to a certain extent more expensive. So what do we need for the business model? We need a data collection of the farmer. We need to know his crop rotation, his organic fertilizers, the straw and the plant residues, and some climate and soil data, mainly the clay content. Then we identify the soils on which the farm, the soils of the farm. Here we have an example of a tool that we developed in Austria, and then we can calculate the site-adapted humus balance. So in this case, I calculated this for the farm, and we have a total humus balance of about 270 kilogram carbon per hectare and year. And the crop rotation of this farm is 1 year maize, under sowing clover grass. Then the second year, the clover grass stays on the field. Then we have rapeseed or line seed, and then we have clover grass again. Here we have considered 2 different soil types, and in total we have a very nice positive amount of 270 kilogram carbon per hectare. So the last step would be just to label the product with maybe this logo, but we have not yet developed it, so it's just in the process. Thank you for your attention, and I hope it wasn't too long.
Thanks. Thank you, Christoph. I think it was interesting. It was a bit longer than 5 minutes, but we tried to catch up with time. And I would like to ask my colleague János Nagy from southwest of Hungary to open his presentation and join us for an overview on what they are doing as a demonstration farm of the University of Agriculture in Hungary for various regenerative practices, including ones related to forage production and carbon farming. So I hope that János is here and can share his slide.
Yes, I'm here.
Hello.
Do you see my screen? No?
Yes, we can.
Yeah.
Not in presentation mode, so you may try not the usual button, but 2 icons. You can share it, and then maybe the 3rd icon.
Oh, no. I'm sorry.
Yeah, try in the bottom, the 3rd icon. So not the one which is active now, but 2 icons to the right. There is 1 icon.
You see it now?
Yeah, we can see it. It's not full size or full screen, but still we can see it.
I'm sorry. I have to practice it, but I would start it just to.
János, sorry, I tell him in Hungarian.
Okay.
Van egy kis ikon, nem a diavetítés ott alul, amire szoktunk nyomni, hanem 2-vel odébb. Ott van egy ilyen 4 kis kockából álló ikon, arra nyomjál rá. De ne lép ki a megosztásból, hanem a PPT-n nyomjál rá. Alul.
Tehát marad ez a share screen.
Igen, az marad, és utána a diavetítésnél pedig a 4 kis kockára nyomjál a diavetítésre. Okay, sorry, some sample of Hungarian speaking.
Ezt nekem nem jön be, sajnálom, László, akkor ez így. Te meg tudod osztani az anyagot, amit
meg, okay. Okay, I will share the presentation. I will move the slide. No problem.
Thank you.
I just need to start the slide. Hopefully I can manage it. And share it. Is it visible for you? Well, not yet. Once more. Okay, and now comes the trick.
Yeah, so it's about the farm, the deer farm. It's a university farm, which is 1,360 hectares altogether, and we are running mainly game on the farm: red deer, fallow deer, mouflons, and some domesticated animals. On the next slide, please. Yeah, see, it's about 1,000 hectare arable land, and we have nearly 2,000 big animals, grazing animals. and we also doing some kind of research on deer management and hunting. But we, as you can see, we have horses, water buffaloes, and donkeys. And some of our activities is tourism. We have around 25,000 visitors per year. We also have venison processing plant, and as a part of the university, we have practical education for the university people and for farmers as well. But in the last 4 or 5 years, there are a lot of changes. So we also having the problems with the climate change, and the temperature is very high. We have less and less water in the growing season. And as you can see here in the rain simulator, we're also losing quite a lot of the rain which is coming. On the right side, you can see rotational grazed pasture land, which is the water infiltration is about 85–90%, and next to it, so the second from the right is a stock set stocking grazing, which is losing about 80% of the rain, and it's only 8% slope what we have on this simulator, but we are having our areas in a hilly area, so more than 12% or even bigger slopes are here. So that's a very major problem. Just the erosion is more than 80% of the farmland is endangered for erosion. And so we have this question that we have to change, but how? And the decision was made 2 years ago, in 2023, when we were putting all the different kind of animals into 2 big grazing groups. And now you can see donkeys and beef cattle and water buffaloes and horses grazing together. Here is about 270 animals grazing on a 5 hectare areas for 2 days. Normally we try to move them every day, but it's not always easy to organize it. But the rotational grazing is one way what we were choosing and try to carry. But also we need to have cover crops, and we started to plant and graze in 2 main time. One is the autumn time, and we graze them in the winter or early spring, and the summer mixtures, which are sown at the end of April, beginning of May, for the dry period, July, August, and it's has very good results. It's a new idea to grazing the lucerne alfalfa, but in this case we had to cut the lucerne first, and we have made doing swath grazing, which allows us to feed young lucerne after 2 days of wilting. So and also we were reseeding this area at the beginning of November. Next slide, please. We also try to bring in the dry periods, July, August, bales from outside of the farm, which is a very interesting topic. And after the first year, we see quite positive results. Just we were watching the earthworms numbers on those areas. We were using this technique and doubled or tripled the earthworms number on those areas. But there are other monitoring programs as well. The Savory Institute was doing the AOV test in 2024, and with the university researchers, we started a research program for set stocking and rotational grazing to compare this two technique for at least 3 years or even more year time frame. And last year we decided to step in the carbon program just to have more data on the carbon sequestration, or how these farming techniques or this changed management, what I was talking about, how it's affect the soil carbon profile. And let's meet in Düsseldorf, and I would be happy to show you around if in a case somebody would come into this region of the country. Thank you very much.
Thanks a lot, János. And we will jump to the next presentation directly from your ending words that you joined a carbon program last year, and that is called the Black Soil program, if I could call it. Maybe Ambrus, who is our next speaker, can inform us better about the current title and give us a short introduction on this program.
Yes, do you hear me?
Yes.
Do you see my presentation?
Yes.
Great. Okay, then good afternoon from Kóspallak. Hi everyone. Kóspallak is in the northern part of Hungary, so quite far from Böszinfa. Thank you very much for inviting us here. It's an honor to be here at this conference and to talk a little bit about what we think is really important in the field of regen ag and carbon farming. I would like to say a few words about our team. We are talajreform or soil reform, if I want to translate, but although soil revolution sounds a little bit better in English, I guess. Black Soil is the brand name of our carbon program, but more on that later. So the company was founded 10 years ago by John Bodrici, the bearded gentleman in the middle. And since then, we have been present in Hungary and in the surrounding countries as a team of regenerative agriculture consultants. And because we believe that using the right cover crop seed mix is the make or break of the matter within regen ag, we specialized in cover crops. We understand all the aspects of regenerative agriculture and regenerative transition, but our expertise is cover crops. I have only got 5 minutes, so I'll be very short in my argument. I apologize for that. So, we have been using soil. We have been using soil so far, and we were sure it is a renewable resource. But it's only a conditionally renewable resource, and we tend to forget about that. And we thought that if we rotated the stalk residue and the manure in, it would increase the organic matter content of the soil, and we thought is the condition to renew it. But it's not the residue and the manure that regenerates our soil the most. It's living roots in the soil all the time. The plant produces liquid sugars through photosynthesis to feed itself and also to feed soil microbiology. it's the root exudates itself. This is called the liquid carbon pathway. The whole soil food web based on the microbiology on bacteria and on fungi. And you can see them in this picture as well. So in the photo on the left is James White's photo. You can see billions of bacteria condensing near the root tip. And the photo on the right, it's from Dr. Christine Jones. It shows the mycorrhizal fungi threads between the root wall and the soil grain. Dr. Christine Jones, James White, Noah Sokol, and many microbiologists have shown us that there is many times more carbon formation through the liquid carbon pathway than through mulching. John says that the carbon formation is 5 to 30 times faster. Noah Sokol says it is 3 to 13 times faster than mulching. If there aren't any crops or weeds on the land, or if the plant microbiology connection is made impossible by lots and lots of fertilizers, the biological activity of the soil just ceases to exist. So we thought that's how organic matter and nutrient cycling works. But this research shows what an amazing impact of the presence of living roots has. In Sokol's research, there were 3 field plots. The first one had living cover crops in the growing season and was left there as a mulch. The second field got the same cover crop, but the residue was transferred to the third field, which was totally bare before the residue. And the result is amazing. The dissolved organic carbon and microbial biomass carbon levels in both fields were orders of magnitude higher than in the mulch-only field. Farmers often see the use of cover crops as unnecessary and expensive, but this research also demonstrates that diverse cover crops should be sown for their diverse root systems. The best case scenario for cover crop termination is grazing by cattle or sheep, by far the best case scenario, or terminated by frost and not with machines or herbicides. But it can also be taken off the land for forage if the quality is right. My last message is that you are a regenerative farmer if you can prove it with data. That's why we started sampling our partners' lands, where the biggest focus is on changes in soil carbon content, so the farmer can even sell the resulting surplus in the form of carbon credits. But beyond that, for the data alone is worth the sampling. I hope that I have provided the audience with valuable insights, and thank you very much for your attention.
Thanks a lot, Ambrosch. Nice that you mainly focused on the technical aspect, and you were very modest not to promote the black soil project, what we joined with our university farms, and you are also the topic of our business model testing. So if you don't mind, I just put the link to the chat if people are interested about this to be a carbon credit oriented model in the future. And I would like to invite now my colleague in OMKi, Judith. Please share your slide and give us a few sentences about our own organization's activities. OMKi is a partner in Climate Smart Advisors project. Thanks.
Thank you for the invitation. And I see the others screen sharing. Shall I replace? Okay.
You can.
Okay. Okay, do you see my presentation correctly?
Yes.
Okay, then.
The same like with Janos. If you click on the second icon beside the usual one on the bottom.
Okay, it's strange because for me it shows.
But yeah, sharing.
Okay.
Yeah, I know, but you shouldn't stop sharing, but just choose the next button to project the slide.
Is it better now?
Yeah.
Okay. Then thank you for the invitation. And when Laszlo asked me to present the OMKi's research related to carbon and forest production, then I was in a little trouble because, to tell the truth, OMKi doesn't have much explicit research on forage production. But when I was thinking about carefully what we are doing, then I realized a lot of research related to forage production, carbon, and climate change. But now my problem is that I cannot change slides. Yeah, got it. So to start with my favorite one and follow up on Ambros's presentation, that OMKi also is interested how regenerative practices can perform in organic farming. And I consider myself as a soil scientist, and I love all the practices and methods and views that does good for soil, and the regenerative agriculture does that one. And I would like to join also that cover cropping is a very important practice, not only in the point of view of increasing carbon content in soils, but the link with forage production that I would like to emphasize here. So many times cover crops and intercropping and intercrops are usually contains forage legumes, and they are utilized as forage for animals, and some of our partner farmers does that. And the other important point of regenerative agriculture is integration of animals into the arable system. And one of our partner farmers says that to have animal in farm, it's a very good opportunity, because if any crops fail or doesn't have a right quality or get more wheat, then it can be still utilized by animals, or grazing, or cutting and giving them to hay. Basically, it's true for cattle. So the other thing that we were interested in regarding to forage production is organic soybean, because to get it a GMO-free soybean getting a bigger and bigger challenge. So we have variety tests and some other aspects of soybean production. And when we think about adaptation to climate change, then alternative crops are coming into the focus. Some of them are pulses like chickpeas, lentils, and peas, and some other crops that can resist heat and lack of precipitation and drought getting more and more important. So we started to focus on some winter varieties of spring ones like peas to utilize more the winter's precipitation. Just to illustrate this one and why we started just a new research topic was a variety test in OMKi on the millet, because we realized that the day maximum temperature during summer getting higher and higher, and you see that even the crop, the corn is suffering nowadays, at least in the past 2 or 3 years in Hungary. So with shorter growing period, it's getting more important, and try some alternative crops for them. And the other important aspect that I would like to highlight is OMKi is doing research together with farmers. We have our on-farm research network, and we would like to help organic farming in Hungary and beyond, and to have directly farmers. It means that we set up on-farm research together with the farmers. It means that we find research topics that is interesting to the farmers, feasible on to perform on the farm, and of course it meets OMKi's interest in the research topic, and it is able to be financed. So we plan the experiments together, and then share the data and or the research findings, and to get with farmers, but not only with the farmer who take part in this experiment, but in a wider region. And so we usually organize several field days and conferences to share the research results. And the other thing, what I think is important, to share all the processes working behind each techniques and management steps, and the consequences of different management options to soil and nutrient management and carbon cycle and nutrient cycle in the soil. So for 5 minutes is not too much. This is just a short figure how this on-farm method is look like. But I think my time is over, so I thank you for your attention, and open for questions and any context later on. Thank you very much.
Thank you. Thanks a lot, Judith, also for keeping the time. And now, Alex, I think maybe we are a bit late, but our time frame can run a little bit longer. So the floor is yours.
Thank you, Laszlo. Thank you to the other people that speak. That I think was a very interesting speech, and I took some note for maybe potential interaction also between us. I'm Alessandro Zatta. I'm the team leader in Climate Fardimo. I work on research center of animal production, and I prepared the presentation. Yes, Arianna prepared the presentation, and we will present some results of our project that link the carbon farming with the forest production. So Arianna, the floor is yours, and okay.
Thanks, Alessandro. Good morning, everyone. I am Arianna Pignanoli, and I am advisor in Climate Fardimo, and also I am involved as advisor in Climate Smart Advisor. In this presentation, I will introduce the experiences of carbon farming practices for forage production in Italy and its impact on climate change. Climate change in Mediterranean area. The climate change is characterized by increase in average and minimum temperature, increased frequency of extreme weather events like heat waves, droughts, and episodes of heavy rainfall, reduction in average annual rainfall and river flow. Mediterranean area is considered a hotspot. That is mean that this phenomenon is more intensive and more frequent. This is confirmed by Laszlo in this scientific paper published in Nature. Identify hotspot area depicted in this figure, in which he assessed some hotspot. Some hotspot based on two indexes due to the effect of climate change phenomena like heat waves, intensive rainfall, and droughts. But how is climate changing in Italy? The Italian Superior Institute for Environmental Research report analysis of variation of temperature in the last 30 years in the north, center, and south of Italy. We can observe an increase in an increase of temperature in 2023 compared to the trend of last 30 years. This increase was recorded for all months of the year, except for April and May, in which there is a decrease. We can see for as regard rainfall, we can see that we have the same trend for May and June in the north, center, and south of Italy. We have the same trend in this part of the country, but there is no difference between rainfall in 2023 year compared to the trend of last 30 years. But in this month, May, June, there is a increase of rainfall. We identify and also apply some mitigation and adaptation strategies to produce forage with this climate change condition. Like, for example, reduce deep tillage, for example, minimum tillage and or no tillage techniques. As regard biodiversity and crop rotation, we selected crops and genotypes adapted to new weather conditions, for example, from south of Italy. And crop association, lucerne, wheat and panicum, wheat and pea forage. And also we selected some techniques for maintains permanent grassland. And also we selected some techniques to use efficiency use of manure and slurry. For example, maturation, manure and slurry, and identify the correct time according to the crop need for spreading manure and slurry. The best practice to increase the forage production and reduce its impact on climate change is increase utilization agricultural area for legume crops, abandoning monoculture and applying crop rotation, increasing double cropping, improving efficiency of crop conservation, reintroducing meadows, and reducing chemical nitrogen fertilizer, for example, through efficient use of manure and slurry. As regards herd feeding and management, use of high quality of forage, adaptation of innovative ensiling techniques, legumes forage instead of soybean meal, and other optimal herd management as regards fertility, welfare, and diseases. As regards animal manure and slurry management, storage management, some techniques like acidification, covering or crusting, no storage and direct use for biogas, timing of distribution, and solid liquid separation for a better use of on field, and also timing of spreading and application of application techniques and dosage. Before we talk about linkage between forage system and carbon farming. This map represents the organic carbon map of Emilia-Romagna. Highlights the area with high level of carbon that is due to the Parmigiano Reggiano cheese production and pigs farms. So this area where there is a high level of organic carbon is due to the applying of manure and the contribute of livestock on the fertility of soil. So, while agricultural and livestock production generates greenhouse gases, the return of manure and slurry to the soil and multi-annual crops result in the carbon sequestration. So, carbon sequestration with its positive effect on reducing of carbon dioxide can't be separated from the environmental assessment of livestock production. So in this graph shows the results of the European project called Forage for Climate, which analyze different forage systems. Parmigiano Reggiano with high forage system, Parmigiano Reggiano with high and fresh forage, corn silage, top quality silage, mixed and winter crop silage. So this graph reports the level of carbon in the soil expressed in tons of carbon per hectare. After in the 3 years of the project, from 2016 to 2019, after the application of best practices. So in all forage system, the carbon level in the soil is increased after the application of these best practices. This second graph reports the environmental impact of the forage system production expressed on kilogram of carbon dioxide per milk production, fat, protein, corrected milk. After applying best practices during 3 years of project, all forage systems show a reduction of carbon footprint for all forage systems. There is also even greater reduction for all forage system if we included in the assessment the carbon sequestration. So, for example, if we consider the carbon sequestration in the carbon footprint analysis and the results, we can see, for example, pear, Parmigiano Reggiano, hay, and fresh forage system passes from 1.60 kilogram of carbon dioxide to 1.30 kilogram of carbon dioxide. So carbon sequestration is a very important phenomenon for fertility for soil, but also in the concept of environmental assessment of forage system. The importance of permanent meadow connected to the production of Parmigiano Reggiano for maintenance of carbon in the soil is reported in this graph. This graph represents the trend of carbon in the soil from with the presence of permanent meadow. With the presence of permanent meadow, in the first 20 years, the level of carbon in the soil increases from 110 to 125 ton of carbon per hectare. After plowing, the level of carbon in the soil, after plowing the soil, the level of carbon in the soil decrease from 125 ton of kilogram per hectare to 110 ton of kilogram per hectare. So is the maintenance of permanent meadow is very important to guarantee the fertility of soil, and we know that we are losing part of this permanent meadow due to some management factors. For example, increase forage production for animal feeding. So is very important for farm maintain this type of crop to maintain the fertility of soil. So the area highlighted in this map, known as Romagna, shows less soil carbon content compared to the part of Parmigiano Reggiano production, this area. Because we don't have dairy farm, but in this area is produced lucerne, that is devoted to the alpha production that goes to animal feed for Parmigiano Reggiano production. In the operational group called Medicarbonio, we analyzed and compared 4 types of farms. Cereal farms with annual crops, and cereal farms with alfalfa, dairy farms with annual crops, and dairy farms with permanent meadow. This graph represents is reporting the level of cereal farms with alfalfa. That is the level of carbon for these farms is higher than cereal farms with annual crops, but is less than dairy farm due to the contribute of dairy farm to the level of carbon in the soil for slurry and manure. Then we talk about forage production in the Apennines area that represent the mountain and hill area highlighted in this map. This area is dedicated to the production of Parmigiano Reggiano cheese. So in this area, we have the contribute of livestock and for maintain the fertility of soil. In the first time in this area is characterized by soil degradation due to deep tillage and short crop rotation, combined with bad use of manure and slurry due to less maturation on the manure and incorrect spreading time. This effect caused depleted meadows. So in the European project Life Agriculture, the project that is carried out for 3 years, we have optimized the manure spreading and reduced tillage, such as minimum tillage and direct seeding. The effect of these practices is to reduce carbon footprint. In this case, the carbon footprint is reduced by 16% after applying the best practices. And in particular, we produced more and better quality of forage. And this best practice, as a result, animal feeding purchase and enteric emission were reduced. So the impact of this voice are reduced. And also best practices, for example, minimum and zero tillage, increase also the carbon sequestration. So carbon sequestration and the reducing of animal feeding and also enteric emission caused the the reducing of carbon footprint. So in conclusion, these types of forage system influence soil carbon levels and therefore their environmental impact. The results of the projects show that the forage system with multi-annual crop rotation, permanent grassland, and input of livestock manure increase the soil organic carbon and reduce environmental impact. Carbon farming practices are strategic for agricultural systems to mitigate and adapt to climate change. Thank you for your attention.
Thank you, Arianna, for your presentation. So you saw that we worked on different European project and national project where we applied the best practice that Arianna showed, and we evaluated also the impact of this best practice, not only on forage production but also in terms of emission of the whole system. And I just would like to underline that part of the farms where we took the data, the soil and the best practice now is part of the network of the demo farm. So this project is still linked with the Clemer demo because I repeat, the farm that applied this best practice now is a demo farm in Clemer demo project. So I think this is. So if you want to come in Italy and see this farm, you are welcome, of course.
Okay, thanks, Alex. Because our time is more or less up. As compared to the planned 1 hour 15 minutes maximum, I think we still should open opportunity for questions. I saw some good discussion on the chat, what's going on. If someone would like to ask directly, or speakers are still here, so if was anything unclear, you can use the time now. We will share the presentations and we will prepare one-page article on our own institute's websites with all the contacts of emails and maybe not the phone numbers, but you will get contacts to the speakers as well if you are interested in the topics in more detail, because that was like just a quick introduction, at least from our side in Hungary and Austria. Okay, so if no question, we can wait a few more seconds, but then I would like to wish a nice sunny afternoon. It is quite improving weather in Budapest, where I'm staying at the moment in the middle of the country, and so have a nice afternoon, a good week, and keep in touch, and we will see each other during the next General Assembly meeting. Okay, bye-bye, and thanks for coming, and I hope it was useful.
Thank you very much. Bye, everyone.
Thank you.
Bye. Thank you.
Bye.
Thank you. Bye.